Hi everyone, so this is the range extender engine out of the van, and I finally identified the root cause of how it was misfiring when cold and not giving me full power until it was fully up to temperature. And this problem was caused by the head gasket. The engine was constantly blowing head gaskets. And the root cause of that was, I reckon, when I first tested the engine in the van, it had the original exhaust on it, which would have sat here, and that almost red hot exhaust would have heated the engine up even more. And also the van being quite hot inside, with it being summer, that just overheated the engine and warped the block and also the cylinder head. So I had the old cylinder head, this is a new one here, but I had the old one, and I basically just laid down sandpaper on this table, wet and dry, and then just ground it on the sandpaper until it was perfectly flat again and put it back on. And in that test, I managed to get 4.5 kilowatts out of the engine, which is pretty good. So that gives an idea of how much power this can actually produce. This here is a high compression head, so I'm going to put that on it, and I'm also going to redo the bore inside. As you can see, the bore is quite badly scored on a very certain pattern. The piston as well is not in a very good way. If you look here, you can see that it's scored all over on the side, and if you look around the piston, it's unevenly worn all around, so that definitely suggests to me some sort of bore warping. Now, I've ordered a honing tool, which isn't here yet, but I'll hopefully be able to hone this out until it's very close to perfectly round again, and put the new piston in. And this is a new piston. It's got a sort of dished top on it, so don't know if that's going to improve anything, but a piston should have sort of machined lines along it where it was turned on the lathe, but they've just been totally worn away on the old piston. Other than that, we can see that the engine is otherwise in really good condition. There's not really anything too serious to see here. Very slight scratching on the crankshaft there maybe, but there's no issues. The bearings are totally fine. There's no excessive play in them, if any at all. So that noise that was coming off the engine, where it sounded like it was about to throw a rod out of the crankcase, that was totally just the head gasket. The gas is escaping from the head gasket. And that brings me on to the next problem actually. The head bolts got stripped as well when I tightened it up because of a design issue with this engine. It's just 4 bolts just aren't really suitable, I don't think. Well, 4 M8 bolts, so I've replaced them with M10 threaded rod, which just goes right down into the block, sort of that far, and I've secured those in with JB weld. So I think an engine of this type should really have a minimum of 5 bolts on it, but we've only got 4, so that should hopefully be okay. I think with the high compression head, we should be able to get maybe 5 kilowatts from the engine, but I'm still not sure of the other issue I've been having, where after like maybe about 10 minutes of running at full power, the power output actually drops, even though the throttle's maintaining the fully open position. The engine loses half of its power, so I'm not sure what's going on there, if that was a head gasket or not. I wouldn't have thought so because it wasn't making any weird noises when that was happening, so that leads me to believe that possibly it was excessive compression loss due to the condition of the piston, but I don't know, it's hard to say. It is quite badly scored, so I don't know there. So once the honing tool arrives, I'm going to put this all back together, and then I'll make another video showing some test results of how much power it produces with the new head on it. Another thing I'm working on is extra safety features for the control system for it. So the control system is going to be just one board now, rather than lots of crappy wiring. It'll just all be integrated into one board, apart from the ignition system, which will still be a separate unit. And if we look at the stator, I've got the stator coil over here, I'll just grab it. It's actually got auxiliary windings on it, which I've maybe been over before, but as we can see here, we've got the main three-phase power output, which is high voltage, and unloaded this can actually go up to 600 volts, which is quite a lot. And these two are 12 volt, well, these three pairs here are 12 volt windings, and each of those are just one coil around one of the stator teeth, that's it. Each of these just got one coil. So I'm going to use one of them as the RPM sensor. So the way that will work is I'll just go to a bridge rectifier and a capacitor, and the controller will just measure the voltage and correlate that with the RPM. And if it tries to go over a certain voltage, I'll just set a threshold where if it's going over that, that means something's wrong, that the high voltage cables come loose or the rectifier's blown, and it'll just prevent the engine from overspeeding. Another safety feature is the temperature sensor. I've added this temperature sensor onto the windings so that it just doesn't overheat basically. If it starts to get too hot, the throttle just backs off a bit and it just tries to maintain a certain temperature. So I think it's set to 110 Celsius, and if it starts hitting that, it'll just back off the throttle so it doesn't go over that. So that's probably, I'd say that's for the best. You don't want this thing like disintegrating and melting, so that's a good feature to add. Another thing that would be good to do maybe is just to rewind this totally and just have it so it's just 3 high voltage windings. That's one other possible option, but that's a lot of work. So I think I could use the other 12 volt winding just to run the other side of the isolation amplifier, which senses the output voltage, rather than using an expensive isolated DC converter chip. I could just use this and it'll just go to a bridge rectifier and a linear regulator, because each of these are isolated from each other. So you've actually got 3 isolated power supplies you can use, which could come in very handy potentially.